This is SpaceTime, Series 20, Episode 99. Coming up on SpaceTime, artificial intelligence used to discover an eighth exoplanet orbiting a distant star. Expedition 54 blasts into orbit carrying a new crew to the International Space Station. And what may be the earliest direct evidence of life on Earth discovered in Western Australia. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Our solar system is now tied for the most number of planets orbiting a single star, following the discovery of an eighth planet orbiting the Sun-like star Kepler 90, some 2,545 light-years away, in the constellation Draco. The planet was discovered in archival data from NASA's planet-hunting Kepler Space Telescope. Kepler looked for planets by searching for a sudden telltale dip in light coming from a star. Those dips could be caused by an orbiting planet passing in front of or transiting the star as seen from Kepler's vantage point. The newly discovered exoplanet, named Kepler 90I, is a sizzling hot rocky world orbiting its host star every 14.4 Earth days. It was found using machine learning, an approach to artificial intelligence in which computers learn. In this case, computers learn to identify planets by looking through the Kepler data stream, searching for changes in starlight caused by an orbiting planet. The discovery, reported in the Astronomical Journal, shows that NASA's archived Kepler data still hosts a treasure trove of discoveries just waiting for the right technology to unearth them. Researchers achieved their discovery by training an artificial neural network computer to learn how to identify exoplanets through light readings recorded by Kepler. Machine learning had previously been used in searches of the Kepler database, and this continued research demonstrates that neural networks really are a promising tool in finding some of the weakest signals of distant worlds. Other planetary systems probably hold more promise for life than Kepler 90. About 30% larger than the Earth, Kepler 90I is so close to its host star that its average surface temperature is believed to be about 430 degrees Celsius. That's on par with Mercury, the nearest planet to the Sun. Its outermost planet, Kepler 90H, orbits at a similar distance to its star as Earth does to the Sun. The Kepler 90 star system is like a mini version of our own solar system. You've got a whole bunch of small planets on the inside, with big planets further out. But unlike our solar system, everything in Kepler 90 is scrunched much closer together. Kepler's 4-year data set consists of 35,000 possible planetary signatures. Automated tests and sometimes human eyes are used to verify the most promising signals in this data. However, the weakest signals are often missed using this method, and that's where AI comes in. The authors trained their neural network to identify transiting exoplanets using a set of 1,500 previously vetted signals from the Kepler exoplanet catalogue. In the test set, the neural network correctly identified true planets from false positives 96% of the time. Then, with the neural network having learned to detect the pattern of a transiting exoplanet, the researchers directed their model to search for weaker signals in some 670 star systems that already had multiple known planets. You see, the assumption is that multiple planetary systems would be the best places to look for more exoplanets. And Kepler 90I wasn't the only discovery the neural network made. A sixth planet was also detected in another star system, Kepler 80. This one, the Earth-sized Kepler 80G, and 4 of its neighbouring planets form what's called a resonant chain, where planets are locked by their mutual gravity into a rhythmic orbital dance. The result's an extremely stable system, very similar to the 7 planets in the TRAPPIST-1 system. The team are now planning to apply their neural network to Kepler's full set of more than 150,000 stars. Kepler has produced an unprecedented data set for exoplanet hunting. But after gazing at one patch of space for more than 4 years, the spacecraft's now operating on an extended mission, switching its field of view every 80 days. I'm Stuart Gary. You're listening to SpaceTime. NASA has accelerated its plans to send a spacecraft to the asteroid 16 Psyche. The mission, which was slated to launch in 2023, will now fly at least a year earlier. 16 Psyche is a 252-kilometre wide main belt asteroid orbiting the Sun between Mars and Jupiter. It's thought to be the exposed metallic iron core of what was once a far larger Mars-sized protoplanet that was destroyed in some violent collision during the early solar system's history. With its mantle and crust ripped off, all that remains of the original planet is its iron core. The Psyche spacecraft is being built by NASA's Jet Propulsion Laboratory in Pasadena, California, in collaboration with Space Systems Loral and Arizona State University. It'll use a solar electric propulsion system and take at least 4 years with the help of gravity assist to intercept the asteroid. Once in orbit, the spacecraft will spend at least 20 months studying this unusual space rock using a multispectral imager, a magnetometer, a gamma-ray and neutron spectrometer, and an X-band radiogravity experiment. The mission will allow scientists to better understand differentiation, the process in planetary formation, which involves heavier elements sinking towards the centre and lighter elements floating towards the top of a molten planet as it forms. The Psyche mission will characterise the asteroid's geology, shape, elemental composition, magnetic field, and mass distribution. Scientists want to know if 16 Psyche really is the stripped core of a differentiated planetesimal, or whether it simply formed as an iron-rich body. They also want to learn more about the building blocks of planets and how their compositions differed depending on how far from the Sun they formed. If 16 Psyche was stripped of its mantle, then when and how did that occur? Also, if 16 Psyche was once molten, did it solidify from the inside out or from the outside in? Did 16 Psyche produce a geodynamo-generated magnetic field as it cooled? What are the major alloy elements that coexist in the iron metal of the core? What are the key characteristics of the geologic surface and global topography? Does 16 Psyche look radically different from known stony and icy bodies? And how do craters on a metal body differ from those on a rocky or icy asteroid? The spacecraft will also test a new experimental laser communication system called DSOC, which stands for Deep Space Optical Communications. Scientists expect it will increase spacecraft communications performance and efficiency by up to 100 times over conventional radio communication systems. To find out more about the mission, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Let's look at this Psyche mission of NASA's to take a look at what is seemingly an unusual asteroid.
It is a very unusual asteroid, and it's one which I hold in some affection, Andrew, because when I was embarking on my master's degree work, my topic was understanding asteroid orbits. And so I had to observe some asteroids and work out their orbits and calculate all that stuff. And it almost drove me mad, but it nevertheless was interesting stuff. And the first asteroid that I tried out all my new sparkling software that I'd written on was Psyche, Psyche, slightly psychological, I guess you could call it. It was the 16th asteroid to be discovered, so it's usually known as 16 Psyche. And 16 Psyche plays its part in my master's thesis at the University of St Andrews. But it's now known, which it certainly wasn't back then, this is hundreds of years ago, we now know that Psyche is probably unique among the asteroid belt, because whereas most asteroids are pretty stony objects, they're rather rocky, this one is made almost entirely of metal. It's a nickel-iron asteroid. So its composition, could hardly be more different from your average asteroid. And that makes it of interest to science, because we think that Psyche was probably once the core of a planet that was being assembled within the solar system. So the way planets form is you start off with a cloud of gas and dust, and that collapses under its own gravity. And at the middle, you get a huge ball of hot gas, which is like the sun. That's the star. But the dust and the gas, the remnant gas, swirls into a disk around it. We call it a protoplanetary disk. And within that disk, you start to get planets forming. And the bottom line is that bits of dusty material stick together, and eventually gravity pulls more and more of them together till you've got something the size of a football field, and then they stick together and you get something the size of the moon. You build what are called planetesimals. These are sort of baby planets. And then you get to a stage where the thing is big enough for its own gravity to pull it into a spherical shape. And in doing that, it heats the planet. It's probably hot anyway from the collisions of material. But all the heavier elements sink to the middle. And so you get the rocky stuff forms the mantle on the outside. The heavy elements sink to the middle. It's a process called differentiation. And so what it means is that you form these objects which have got a metallic core and then a rocky mantle over the top of it. And that's basically the structure of the Earth. And we think the other planets, certainly the other rocky planets. Mm-hmm. So at the middle of planets, typically, you're going to find a metallic core. But in the early history of the solar system, planets were not in their well-behaved, circular orbits that we have now. They were charging into one another in a fairly random fashion.
Yeah, it was a fairly cataclysmic time in the history of the universe.
That's right, there was. In fact, about within the first 600 or 700 million years of the formation of the solar system, that sounds like a long time, but the solar system's a lot older than that. It's about 4.6 billion years old. But within those first few 100 million years, there was an episode called the Late Heavy Bombardment. And that was a time when, lots of things were charging around in the solar system. And planets not only were being built, but they were also being demolished. The process is a kind of cyclic one. And so somewhere along the line, a big object hit this protoplanet, this thing that was going to turn into a planet, and knocked it to pieces. And one of the remnants of that is Psyche, because Psyche is the remnant of the core of this object that never made it to planethood. And that makes it very interesting to planetary scientists. So the plan is to send this spacecraft, which will investigate the surface of Psyche. We've no idea what a metallic asteroid surface will be like. It might be quite shiny and polished. It might be overlain with dust. It might have all kinds of bells and whistles on the surface, rather than just the craters and mountains that we expect to find on a rocky asteroid. So the spacecraft will be equipped with magnetometers and multispectral imagers and gamma ray spectrometers, neutron spectrometers, the whole remit of stuff that we take into space to investigate these other worlds, as well, of course, as cameras and things of that sort. The reason why we're talking about this today is that the mission has actually had a bit of a boost, because the original plan was that this mission would not be launched until 2023 and was going to take, I think, something like 6 years to get to Psyche. But the mission scientists have been instructed by NASA to look at bringing it earlier. And in fact, they've got a new plan, which involves a gravity assist from the planet Mars. That's when you fly by a planet and get a kick from it to boost your speed. It involves now a launch in 2022, the northern summer of 2022, and a planned arrival at Psyche, whose orbit is between the orbits of Mars and Jupiter. It's what we call a main belt asteroid. Mid-2026, so 9 years' time, we will expect to see that. Actually, it's 4 years earlier than was planned. It was originally planned to get there in 2030. So for Psyche enthusiasts like me, that's really great news, because, I might last that long. You and I might still be talking about this stuff.
I should hope so, Fred.
Yes, I do too.
The thing is, I would imagine that they would have already laid down their plans, done their calculations, worked out what they needed to work out, fuel loads, trajectories, escape velocity, or whatever else, for the original plan. And now they've had to work it all out again. Surely that'd be a mixture of joy and frustration.
Probably, that's right. I think a number of things, though, have made people fairly joyous about this, because one of the things about the new trajectory that the spacecraft will be on is that it doesn't go quite as close to the sun as was originally planned. It was going to pass, I don't know how many million kilometers away, but close to the sun and close enough to give the mission scientists a bit of discomfort. So basically, you need less heat protection now for the spacecraft. It doesn't need to have all the reflective armouring that you would have needed before.
And they'll save on 30 plus sunscreen, so that's good too.
That's right, yeah. Actually, they use 50 plus sunscreen.
Do they?
Yeah, no, 30 plus.
I'm told it doesn't make much difference.
No, that's right. It certainly doesn't if you plaster it on a spacecraft that you then launch through the atmosphere.
And I gather that the window of opportunity to connect with Psyche is pretty wide, because you don't often have these big variations in time when it comes to intercepting objects like this?
It really depends on, the relative positions between Psyche and the Earth when their orbital parameters all align. Of course, that's one of the issues about human spaceflight to Mars, because there are only certain times when you can make the transfer between the Earth and Mars. And then when you get there, you've got to wait a year and a half or something before you can get back because of the alignment that you need. So you're quite right. This is a one-way trip. The spacecraft will wind up in orbit around Psyche and will basically, spend the rest of its days there. There's no problem about bringing it back. It's certainly not going to bring back any sample return from Psyche. All that we will learn about that weird asteroid will come from the equipment on board and the images and things of that sort. But I think it's pretty exciting stuff.
It is, and we may well then learn a bit more about what goes on inside our own planet. We haven't seen our core. We haven't.
Exactly. That's the whole nub of the issue, that the metallic cores of planets are really, you've got to work pretty hard to get any information about them at all. In fact, most of what we know about the core of the Earth comes from seismic observations, where you get earthquakes and you watch the way the seismic waves are refracted and reflected within the Earth. That's what tells you what the Earth's structure's like, plus a bit of modelling to try and understand what a planet would look like, a hypothetical planet, if you put it together. But to have the opportunity to investigate something firsthand is really remarkable.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Three Expedition 54 crew members have blasted into orbit on a 2-day flight to the International Space Station. The launch aboard a Soyuz FG rocket took place under clear blue skies from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan.
Confirmation of auto-sequence start, the second umbilical separating. The launch command has been issued. And with that, we see the fires lit, the engines start to roar, and lift off. Scott Tingle, Anton Shkaplerov, and Norishiki Kanai on their way to the International Space Station. Anton Shkaplerov already calling down everything going well on board, everything reported fine. Performance calls coming in, the engines performing nominally or normally, getting good first stage performance. The Soyuz delivering 930,000 pounds of thrust in those 4 boosters in that single core engine. The first stage measures 68 feet in length and 24 feet in diameter and is going to burn liquid fuel for the first 2 minutes and 6 seconds into the flight. Still getting good performance calls, the crew feeling good as they light up the sky over there in Baikonur. Again, it's a clear day, pretty spectacular views of the rocket as it makes its 8-minute 45-second climb into orbit. Already more than 1 minute 45 seconds into the flight, everything's still going well with the rocket. The first stage separating, those 4 strap-on boosters breaking away, their job completed, dropping away the rocket at an altitude already of about 28 statute miles, and making what's known the Korolev cross. The 4 engines slowly going to make their way back down here to Earth. The vehicle now being propelled by the core stage, traveling over 3,300 miles an hour already, and getting confirmation that the shroud has been jettisoned. The rocket is about 48 miles in height already. At this point, the vehicle's traveling at a speed of about 4,700 miles an hour. And again, the second stage, that core stage performing as expected. It measures 56 feet in length, 13.5 feet in diameter, with that single engine and 4 fuel chambers. Under that second stage right now, we're already 3 minutes and 50 seconds since the liftoff. the rocket as it continues to climb to orbit. That second stage with the single engine and 4 fuel chambers provides between 178,000 and 222,000 pounds of thrust, depending on the altitude, for its 3 minutes and 28 seconds of operation. It's going to continue burning for about 30 more seconds, and then it's going to use what's again known as a hot stage technique, where the third stage is actually going to ignite while the second is still burning. That's why it has that lattice-like structure between the two stages, an open area between the second and third. And now standing by for that hot staging and the separation of the second stage, and the visiting vehicle officer confirming the second stage has separated, confirmed. The booster separating at an altitude of about 105 miles. It's now being propelled by the single engine of the third stage, providing 67,000 pounds of thrust, and it's going to burn for another 4 minutes and 2 seconds. That's going to put them into their preliminary orbit. So this is the third and final stage of this flight. Everything going great so far. Getting good reports from the crew, everyone feeling great. The first and second stages of the rocket performing without any issues before dropping away, now being propelled by the third stage. Still getting reports all the control systems on the vehicle operating nominally or normally. The third stage still has about 1 minute and 45 seconds to go before it gets ready to cut off and separate. And once that third stage delivers the Soyuz into orbit, a number of pre-programmed commands will be executed to prepare the Soyuz for flying around in low Earth orbit. And that'll include deploying the solar arrays and a number of navigational antennas on the top of the vehicle. 7.5 minutes and counting up from liftoff. At this point, the vehicle traveling at a velocity of almost 13,500 miles an hour. And we're a little over 8 minutes since the launch. The crew on station getting the call. The 3 new crew members are well on their way already. The third stage continuing to fire should have another 20 seconds or so, and then we might see a little bit of a jolt for these crew members inside as the third stage cuts off and separates. Standing by in the next couple of seconds for third stage shutdown. The third stage confirmed to be separated, and good news from the visiting vehicle officer, all of the antennas and the solar arrays deployed successfully. So confirmation of spacecraft separation coming at an altitude of about 126 or 125 statute miles. The third stage does an avoidance maneuver by opening a valve on its liquid oxygen tank and drops away back down towards the Earth.
The Soyuz MA-07 capsule was placed on the longer 34-orbit 2-day rendezvous flight profile instead of the usual 6-hour 4-orbit fast rendezvous flight path, so that ground teams could be home in time for the holidays. Apparently, it would have taken more time to set up and coordinate the fast-track flight path. 2 days after launching, the Soyuz docked with the space station's Russian Razvet module. The new crew members will join the 3 existing Expedition 53-54 crew, conducting some 250 experiments in microgravity. These investigations range from research in biology, earth sciences, human research, physical sciences, and technology development. The new crew's arrival also sees the continuing long-term increase in crew size on the US segment of the space station from 3 to 4 crew members. This allows NASA to maximise the time dedicated to research on the space station. While the existing Expedition 53-54 crew will leave in February, the new arrivals will remain on station until April. The launch marked the 62nd flight of the 49-metre-tall FG version of Sergei Korolyov's famous R-7 rocket, first flown in 1957. The FG version of Soyuz began flying in 2001. The mission's Soyuz MS-07 capsule also represented the 136th flight of a manned Soyuz capsule since its introduction in the 1960s as a replacement for the earlier Vostok and then Voskhod capsules. I'm Stuart Gary. You're listening to SpaceTime. Well, they say what goes up must come down, and just days before the Expedition 54 crew blasted into orbit, 3 Expedition 52 crew members returned safely to Earth following their 5-month orbit aboard the International Space Station.
And physical separation and undocking confirmed. 11:14 p.m. Central Time, 12:14 a.m. Eastern Time, with the station flying 255 statute miles over the southern part of Mongolia.
Okay, so the separation is smooth.
So everything progressing smoothly with the spacecraft. Should see that separation burn, and you can see the rate now picking up but that separation burn has begun. The Soyuz now moving a little bit quicker away from the International Space Station, firing of the thruster to carry it out and away. A quick 8-second firing of the thrusters reported to have gone nominally. The burn already completed, and everything's still going extremely smoothly with this departure so far this evening. The Soyuz MS-05 spacecraft continuing to retreat from view. 3 crew members, Sergei Ryazanskiy of Roscosmos, Randy Bresnik of NASA, and Paolo Nespoli of ESA, the European Space Agency, step 2 complete of their departure, and they are now on their way home. The Soyuz expelling some of that heat still from that re-entry. This is now out of the plasma and fully under its main parachute, continuing to descend. Clear skies look to be greeting the Soyuz spacecraft as they'll soon be on the ground in colder temperatures. But again, this main parachute going to slow the descent of the Soyuz spacecraft down to all the way to 7.2 meters per second.
Pressure is dropping.
Just about 8.5 minutes away from the planned landing. Soyuz venting some of the excess attitude control thruster gassing, believed to be hydrogen peroxide used for that control. Continuing to descend under that main parachute, continuing to slow. Again, this to slow it most of the way down, and then when the vehicle is just about a meter above the ground, we'll fire those soft landing engines, fire to a final descent rate of about 1.5 meters per second before that final touchdown. And we should be just about 5 minutes away from touchdown of the descent module of the Soyuz MS-05 spacecraft. NASA astronaut Randy Bresnik on board, along with Russian cosmonaut Sergei Ryazanskiy and Italian astronaut Paolo Nespoli.
Pressure in is 528 and the altitude is 520. Paolo, what about your ears? They are fine. Thank you. Altitude is 2000 even and the pressure in SR is 508. 1200 meters, copy.
Recall 1,200 meters in altitude still, continuing to slowly float down under that main parachute. 3 crew members inside. Once they're down on the ground, the search and recovery forces will move in quite rapidly to begin getting them out of the capsule. About 1 minute away from the anticipated landing time. We are expecting a bit of snow on the ground for their return, sometimes common in the December months over in Kazakhstan. Standing by for landing. And touchdown. Landing confirmed, 2:37 a.m. Central, 3:37 a.m. Eastern. Randy Bresnik, Sergei Ryazanskiy, and Paolo Nespoli back on planet Earth after a successful stay on board the International Space Station.
Their Soyuz MS-05 capsule touched down on the frozen early morning Kazakhstan steppe 4 hours after undocking from the orbiting outpost 400 kilometers in space. During their 139 days in space, the Expedition 52 crew took part in 240 scientific experiments. This is Space Time. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. And what may be the earliest direct evidence of life on Earth has been discovered in Western Australia. A report in the Proceedings of the National Academy of Sciences claims the newly discovered microscopic fossils are dated at approximately 3.5 billion years in age. The specimens were originally found in 1993, but they were considered to simply be odd minerals resembling biological life forms that were trapped inside a larger rock. But a new analysis has now confirmed that the fossils are of biological origin. The study described 11 microbial fossil specimens stemming from 5 separate taxa. Some were found to be now extinct methane-producing archaea microbes, while others included gamma protobacteria which consume methane, and phototrophic bacteria, which produce energy from sunlight similar to species alive today. Prior to oxygen formation, methane was an important part of Earth's early atmosphere, hence methogens would have been an important part of the ecosystem. The new discovery provides insights into how life formed on Earth and how organisms could survive on an oxygen-free planet. The study will also help scientists in the search for life beyond Earth by changing what could be considered a habitable environment. A new study claims drinking a cup of hot tea every day may be linked to being less likely to develop the serious eye condition glaucoma. The findings, reported in the British Journal of Ophthalmology, are based on data from a US study of 10,000 people. Scientists compared the rates of glaucoma to how often participants consumed different beverages over the past year. Compared with those who didn't drink hot tea every day, those who did were 3/4 less likely to develop the disease. But hot coffee, iced tea or soda pop didn't seem to make any difference. The researchers say more studies need to be done, partly because their research can't show cause and effect, and only 1 in 20 people in the study actually had glaucoma. Some sad news now, and a little Australian native mouse could be about to become extinct. A report in the journal Australian Mammalogy warns that the New Holland mouse hasn't been spotted in its native habitat in Victoria's Otway Ranges since 2003. Scientists say when last seen, populations were already unusually small and extinction-prone, with droughts and wildfires being especially dangerous for the tiny animals. Scientists warn that the species is now unlikely to recover without help to keep population numbers up and protect their habitats. Meanwhile, another study warns that the already endangered Sumatran tiger is now also facing extinction. Tigers on the neighbouring islands of Java, Bali and Singapore all went extinct due to poaching during the 20th century. The new findings, reported in the journal Nature Communications, follows a research expedition tracking the tigers through the jungles for a year. The study, funded by the National Geographic Society, found the big cats were clinging to survival in just a few scattered low-density populations. Apart from poaching, the Sumatran tiger also faces habitat loss due to increased logging operations. Of the habitat the tigers rely on in Sumatra, 17% were deforested between the year 2000 and 2012, primarily for palm oil plantations. Scientists calculate that a Sumatran tiger's home range is roughly 150 square miles, much larger than tiger home ranges in other regions like India. It indicates Sumatran tigers need a large national park or reserve in order to survive. The study found tiger densities were 47% higher in primary versus logged forests, and that extensive clearing of pristine lowland forests has disproportionately reduced tiger numbers. Between 1990 and 2010, Sumatra lost 37% of its primary forests. A new study has confirmed that feathered dinosaurs were riddled with ticks just like modern animals are. The findings, reported in the journal Nature Communications, are based on a 99-million-year-old fossil found in Myanmar. Scientists unearthed the ticks in several specimens in pieces of amber, including one entangled with a dinosaur feather, another engorged with blood, just like in Jurassic Park, and others near a dinosaur nest. The researchers say they have enough evidence here to clearly indicate that ticks fed on feathered dinosaurs. And finally for now, kissing under the mistletoe may be a lovely way to spend the holidays, but it seems the wild version of the parasitic plant can occasionally be a bit too greedy. A report in the journal Environmental Research Letters claims the creeper sometimes kills the very tree it's depending on for its food by sucking up all its water during dry periods. It's well known that mistletoe can kill trees, but the researchers discovered the harm to their hosts was caused by the water-greedy parasites. They say the plants aren't a bad thing for an ecosystem, but too much can mean death for their victims. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.